write a pseudocode or algorithm which can accept two values, calculate the total of the two values, and produce the output on the computer screen. Now this one will be slightly more advanced pseudocode. That the pseudocode should show whereby two values can be entered, like the way you enter either on a calculator, then the two values you want them to be added and the result to come out on the screen. How do you do that? That any application you write, because this is like an application, any application you write, as a pseudocode will say, that application must start. That application number one in the list, it must start. Then number 2, you have to input first number, that it should allow you, that application, it should allow you to enter the first number. We don't know which kind of the number, that's why we just say input first number, because we were told we shall enter two numbers. Then next, assume the first number is number 1. Then you say input second number in bracket num2. Input first number, then you input second number, because you had two numbers. Then after you are done with the entry of two numbers, you are given instructions using pseudocode. Then you will say calculate sum of two numbers. Calculate sum of two numbers, which in bracket you can say sum is the same as taking in first number, add it to the second number. You can put a formula there that to get the sum of two numbers is like taking number 1, add it with the number 2 to get the sum. Calculate. That's why you have used the word calculate. And this word calculate, it means that you are going to process. You are going to process after the input procedure has taken place. Then you will finally say print the sum. After printing the sum, you stop. After printing the sum, you stop. And that one will be the complete program. That one will be the complete pseudocode algorithm showing how the application will be running, but just using simple language. This is a language that can be followed by even a child, that these are instructions on how to write a particular code. But this is not a code, it is simply a plain language showing the steps. That means you can write a very complicated instruction even when you are not a programmer using pseudocode. You simply show you are steps. Then we come to flowchart. Flowchart is a pictorial representation of an algorithm. Flowchart is a pictorial representation of an algorithm. Now, how? We can say a flowchart is useful to illustrate on how a program works, but we need to look at the symbols. We have this symbol here, which means start or stop. Flowchart is another alternative to pseudocode. They are slightly the same, but the flowchart is also another very efficient. Now there is this symbol here, which we use it for start or stop. Start or stop. There is also this symbol, which we use it for input or output symbol. That in the flowchart, when you see this symbol here, it looks like a trapezium. It will mean that you are either inputting or outputting, but you will be labeling inside to know, for someone to know that you are inputting or you are outputting. Then this symbol here, which is a rectangular, this one it means is a processing symbol. This one stands for processing. This stands for processing. Mark these features because a good programmer later on, there are several illustrations that you will either get through a flowchart, or you yourself you may direct people using a flowchart to communicate great ideas in programming. So understanding of these symbols is very important. Then the other symbol here is decision symbol. We shall learn later what you mean by decision. Then the other symbol is data flow. Then we have connector symbol, data flow symbol and connector symbol. You have to show commitment. In order to learn programming, you have to show commitment. These are things you can learn. They don't require 1 day. It's a matter of paying attention and you will get what we mean here. Now, so here we have start, stop, and that is the start, stop symbol. Then here we have input or output that explain the input, which we shall label inside here. Here we have processing, and this is the processing. Here we have decision, and indeed this is the decision box. Here we have data flow, and this indeed is the data flow. Here we have connector, and this indeed is the showing connector. And we shall tell you when you are writing how does it connect. So it's a matter of paying attention in the coming lessons. Then let us give example and say draw a flowchart which can be followed to print on a computer screen as free at last. Now, just like what we did in pseudocode, you say start. Then after start, what follows? We say we are using now the other symbol of data flow. Here it is start. We say print free at last. Remember, this can be either input symbol or output symbol. It can be used, but this time we are using it for printing. So you say print free at last. Then you end the application. Stop. Now this one for start and stop, it looks like a rectangular but with the curve at the end. There are some curves here. Not here, that they are not sharp corners. They are not sharp corners. So don't and they will be smaller. They will be small, showing start and stop. Now here you have written instruction but using the flow chart. Now when we have that, we can come to example 3.4 and say draw a flowchart or algorithm which can accept two values, calculate the total of the two values, and produce the output on the computer screen. Now, this one will be also followed just like we did in pseudocode. We can say example 3.4 flowchart. There we start. Then here we say input num1 and num2. Input num1 and num2, meaning that input number 1 and number 2. It is good to shorten something because if you cannot have space to put a very serious statement here, it will bore. It will bore. So you just say input number 1 and number 2 in short. Then after you say calculate sum. calculate sum. In bracket you can say sum is the same as sum num1 plus num2. To get the sum, you get num1 plus num2, meaning that you get number 1 plus number 2. So the command is calculate sum. The command here is input num1 and num2. The command here is to start the application. This symbol shows input. This symbol stands for input. That's why we say input num1 plus and num2. Then here it is symbol for processing. This rectangular figure is a symbol for processing. That's why you see it like that. Then after, you know very well that after processing you can say, you can now output. You can see this symbol and this symbol it looks the same. While here is the input, here it will be output. Print sum. You have got the feedback now. After printing sum, you come here and say stop or end. So your application is very logically flowing down, whereby you cannot say calculate before you have put number in. It can't calculate unless the numbers are entered. You can't print sum unless they are calculated. You can't stop when you have not started. So this is the clear logic flow, and that's why we call it algorithms. They are steps. Algorithms because they are steps. So from there, we see how we have written good instructions whereby programmers can follow to write codes. Programmers can follow